Going to solve 1390 lead code 4 divisors problem. Here they have given one sort of numbers array with the elements of 21, comma 4, comma 7. They are expecting the result. Each and every element should be in the nums array. It should has 4 divisors, and if it has in 4 set of divisors, then we need to do sum up of all the divisors and we need to return as the result. So for that, the number of digits should be exactly 4 digits. If it has 3 digits means we don't consider this element in the array. So for that my approach is we can follow two sort of base cases. I'll go through the base case. Yeah, this is case 1 p into q. Generally here p and q are the prime numbers, and like we have number 21, right? So for that we are taking two sort of elements, 3 into 7. 3 and 7 are the prime numbers. So for that this case, like exactly the length of the all the divisors should be 4 elements. So for that we are simply sum of all the divisors and we will return as the results. This is the one sort of the case, and another case is that case 2, like p3. Here simply we are p should be the prime number, and we are simply making it over cube, and then just making over the cube. So we are getting like 1 comma 2 comma 4 comma 8 as the divisors. So for this we got length of all the divisors should be 4. So it is exactly the 4 divisors, so we are returning the sum. This is the one sort of base case. So we are going with the code now. Yeah, first of all, simply in the array there was some sort of elements, right? So for that we need to check whether the element is prime number or not. If it is a prime number, then we'll go to the further base cases. If it is not a prime number, we'll simply skip those elements. So for that my approach for the prime number checking, I'm considering prime or not. So for that, I am simply making one sort of def function with the name of prime, and I'm passing one variable as an argument, and I'm just iterating. If the prime number should be less than 2 means we are simply returning the false, because prime number should be starts in the range of 2. So for that, another case to check the prime number for I in range 2 to and we can take up to square root of 2 plus 1. So for that I'm converting the point digits into the integer x 0.5 plus 1. This is our range to identify the prime number, and if it is divisible by x, then we'll simply return 0 and we'll return it as false. Otherwise, to print the prime number, we'll return as a true. Now we are going to check the base cases. So I'm initializing the total value as 0, and I'm taking base case 1. Base case 1. So for that I'm p into q. Here, sorry, I'll go with pq first, and then I'll go to p into q. Pq. So for this case, I'm simply taking one sort of variable p, and I'm initializing the round of here. 1 minute. Yeah, here I'm passing the argument, because just a minute, I'm iterating over for loop and I will go through the approach. P should be the round of n into 1 by 3. If it is like 8, if the cube root of 8 we know as 2 is the prime number. So like that we will check each and everything in the approach. So for that we are identifying like whether the given statement or like base cases are matching or not. After, like, without, if it is not matching to our base cases, we will simply return the result as uh, false, and we'll go for further approaches. Without checking the prime number, we don't able to use this base cases approach. So for that I am simply checking whether the condition if p cube is equals to n, it is nothing but p cube, it is nothing but consider p as an 2, and 2 cube it is nothing but 8. Here we are iterating the element 8. If 8 is equals to 8, and we are checking prime also. So for that I'm passing p as an argument, and here we are simply incrementing the total. How we can increment is that with the range of 1 p square p cube, like that we will do p plus p square plus n it is nothing but an 8 is nothing but an p cube, and simply we will continue this loop until the things works. Mm. And next I am going to check this is the case one for to checking the result, and I'm going to take another base case. So for this base case too, here we are checking p into q sort of prime numbers. So for that I am iterating for loop within the range 2 to int of uh, n 0.5 plus 1. If n modulus I equals to 0, then we simply initialize and will iterate each and every with self-divising. If I not equals to j, and we need to check both the I and j arguments. Here I and j are nothing but p into q, both are the prime numbers. So after that we simply increment the total, and we will add here. We don't need to add p square pq. Here we simply need to pass I and j and n values here, and we will simply break the result, and here I am printing the total. Let us check the normal test cases. Yeah, here like I made some sort of range mistake. Yeah, again we'll check. Yeah, solution is accepted. Now submitting for the hidden test cases. Yeah, all pass. The time complexity for this approach should be big O of n into square root of m. Thank you.